is de behoefte aan het niet.
Hi there, Crazy Jack here, Martin Harvey, aka Crazy Jack, creator of Crazy Jack guitar effects pedals such as the fish face. Here's one I made earlier. And today I'm going to talk about this thing. Okay, this I'm not sure what to call it yet, but basically this is a fuzz pedal in which you can control all the parameters yourself. Yeah. When I came up with this idea, I thought, what can I call it? It's something, you know, a fuzz control where you can you fabricate all the sounds you want. Fuzz Factory. And then I realised someone had already made one of those. Anyway, it's a similar sort of thing. Today's deep dive, I'm going to show you the insides of this and why I built this and what has it got to do with this. Okay, if that's the kind of thing that interests you, if you're a bit of a geek like me and like electronics and guitar amps and pedals and things, stay tuned because I'm going to be doing a deep dive into this, but I'm going to make it a quick deep dive today because some of my videos have been rambling on a bit. Hey, stop there! Okay, here we go. So that's what the video is all about today. Right, here we go. Whoops. Now, as I said, recently, I'm just going to stop this. Oh, here's my YouTube channel, by the way. If you haven't already, please like and subscribe. I think I'm up to 147 subscribers at the moment. I'm hoping to make 10,000 by Christmas. So come on, you know you can help. Yes, come on, press the subscribe. Thank you very much. Okay, on with the video. So yeah, I've been making these things in the last few months and they're selling like hotcakes. I'm calling this the buttons are missing, but at the moment, because this one's just about, I'm waiting for the buttons to come in so I can finish this off and send it out to the customer. This is a standard Dallas Arbiter fuzz face in a tuna tin. Okay, I'll show you the insides quickly. Just like the V-Tronics version, they've got a snap-on plastic cover on the bottom, and inside, there's all the, you see all that? There's all the gubbins. It's a fuzz face, 2 transistors. Okay, so I've been making these, and as soon as I launched this product, my local Aldi ran out of these tins, and we had a backlog building up for a couple of weeks while I was trying to source the tins. Anyway, we've caught up now, and hopefully everyone who's been waiting for their fish face, has now got it. I'm going to be talking in this video about this one because this is a modification. It's a variation on this, and here's the story. I had a customer who said, oh, I really like that, I'm going to buy one of those, but what's it like for a bass guitar? And I messaged back and said, I'm really sorry, I really don't know because I don't play bass, I don't have a bass to hand, and I haven't really thought about sort of my fuzz pedals being used with a bass guitar. But as is very often the case when I design something, I do lots of custom projects as well. Going back to the days when I produced my little cigar box amplifiers, very often the customer would say, oh, can you do one in this size, or can I add this switch and that sort of business, or make it USB compatible. So I did, and I built amplifiers in all shapes and sizes now. Let's put these out of the way. Just wanted to show you these, including things where I fit the amplifier inside a baked bean tin. Yes, this is a fully working amplifier, and despite the tiny size, it knocks out a great sound if it's just been used, in your camper van or on the desktop or something. So there's a Crazy Jack amplifier. Check out those. I think I've got a make to order listing on eBay at the moment, but check out the Crazy Jack amps. There's also a Crazy Jack amplifier Facebook page. Here we go. There's the link. So please check that out as well. Anyway, enough about my amps. I wanted to tell you about this thing, didn't I? Okay, so the customer got in touch and said, I got back to him and I said, well, I don't know. I said, but, if you give me a clue as to what sort of thing you'd like, I'll see if I can sort of, adapt my fish face to make it more bass friendly. So he said, well, maybe you could do something like put a switch on it to kick in the bass version tones or whatever. So I did a bit of research and I thought, wow, yeah, do you know, all the parameters on the fish face are customizable. There's not a great, on the fuzz face, the original fuzz face, there's not a great deal to it. It's a very, very simple circuit. In fact, I'll put up a, there you go, there's a schematic. Look, yeah, not a lot to it. Anyway, so you know, if you watch Josh from JHS Pedals, he's got a whole series of videos tweaking things like the fuzz face and the LPB1, the Electro boost pedal and that sort of business. They're very, very similar circuits, but by tweaking the individual components, you get very, very different results. Anyway, so I said to this customer, yeah, give me some time and I'll look into it. And this is what I've come up with. And I'm just finishing wiring this off today. When you come over to the bench in a minute, I'll show you this sort of in close-up and you can see what's going on. But basically it's the standard fish face circuit there with these extra 2 wires coming off, so I can just test this is all working before I snap the wires off and tuck it inside that little hole down there. So basically I'm putting the switch where the LED was, and I've moved the LED down a bit so it's in the center of the tin for the bass version. So this is the fish face buzz. Bass. I'm thinking of calling it the bottom feeder. What do you guys think? Can you guys think of a good name for the fish face bass version? Could it be a sea bass? Sea bass? Yeah. Anyway, so far I like the idea of the name bottom feeder. So, do you like it too? Go on, subscribe. You know you want to. Yay! Thank you very much. Sorry, I really should let my humour go a bit more in these videos. I think I'm going to take the gloves off a bit. Anyway, right, so there we go. So this is the plan. Now, how to do that? How to achieve that? Well, I thought to myself, okay, I'm going to wire up a box in which I break out the standard fuzz face circuit a bit. And here it is. This is sort of like an adaptation of that schematic. Mapped out on the front of a box here, and as you can see there's Q1 and Q2. They're actually on a little board inside. There they are, on a little board inside this thing. Excuse the messiness, I just wired this up quickly just to sort of prove, you know, put it in this cigar box, just proof of concept really, to see if it worked, and it did. And then so that's why I went on to this cake tin version. But anyway, basically there's Q1 and Q2 inside. You know, we're not going to vary those transistors are fixed, although I would like to put some sockets in, and so that I can swap transistors, but I don't like sockets. They tend to wobble about a bit. Anyway, that's another topic. So basically here's the circuit. We have the signal in, which goes to C1, and I've put that on a switch. So we've got the standard, I think it is 2.2 microfarads on C1 there, which I then think I put an option, I can't remember what I did, but I basically put, can you see the two capacitors there? So in one position of the switch, it's got the signal's going through one capacitor and the other one's going through another. I think I might have toggled between 2.2 and 1.1 just to test it out. I can't remember offhand, but it's more the theory that I wanted to test there. So the signal in to Q1, and then the power is coming in up here, and we've got this network of resistors here. And I've used 4 coloured knobs, and you know, because resistors very often, let me see, I'll find you one quickly. Here's a little box of resistors. There you go. There's some 10k resistors. There you go. Is that focusing? Well, you know what I mean. Anyway, so they're blue. So basically, in my colour coding scheme of things, way of doing things, I very often use blue to mean resistors. So there you go, some blue knobs. And we've got R1, which is usually about 33 kilo ohms. That's R2, which is 330 ohms, not kilo ohms, ohms. R3, which is a pretty important one over here, which is specified as 8.2k, but very often I'll use a 10k pot, no, 10k resistor for that one, and 100k on R4, which is the feedback resistor from Q2 back to Q1. And then the signal goes out through C2 up here, and this is important, I'll come back to that in a minute, through C2 out to the volume pot and out. And then also some of the signal is bled out through the fuzz pot here, which bleeds off to earth via C3. Now I decided that C3 I'm going to keep constant for various reasons. I wanted to make everything sort of customizable, but I drew the line at C3. I can't remember the thinking on that at the moment. But basically C1 and C2, the input and the output capacitor here, are the main things that determine the tone, the amount of bass that the circuit allows in the first place and allows out over here, having been amplified. So that's what I wanted to give this customer the option of doing. And I thought, well, while I'm sort of putting in switches to do that, I might as well put in controls so I can mess around with the values of the R1 to R4 as well, because the configuration of this little resistor network up here is very, very important in biasing the transistors. Now, I'm not an electronics expert. I've only really got into it the last couple of years because I'm really interested in developing my amplifiers and now started building pedals. But by biasing, we mean controlling the amount of current that goes into the amplifier itself, and the transistor is basically the amplifier. So if you turn up the resistance, there's less of the signal going through. If you turn down the resistance, more of the signal is going to go through, and so on. So by tweaking these resistors, you are able to control the amount of voltage and current that is going through the other components. And depending on how you tweak these, makes quite a big difference. And I'm going to show you that, so stay tuned for the demo, which is coming up soon, in which I will actually tweak these and you can see the difference. It's quite fun. Did I mention please like and subscribe? I'm trying to get 10,000 subscribers by Christmas. Go on. I'll tell you what I'll do. I think I'm 147 subscribers at the moment. If I get up to 500, I'm going to give away, okay? I'm going to give away one of these, okay? All you have to do to enter is to subscribe, and I will add your handle, your YouTube username, handle, or whatever they call it, to a list, an Excel spreadsheet, and then when I get to 500, I'm going to pick one of those subscribers and they will get a free working, yes, brand new Crazy Jack fish face in the colour of your choice. Okay, they come in blue, brine, yellow, and I've got a greeny one which is a little bit more healthy, spring water flavour. Right, okay, so there we go, giveaway. First time I've done one of those. Right, so here we go. So I built this very, very quickly just to test out the idea, because I wanted to find out which parts of the circuit, which components sort of had the most effect on changing the tone, which would make it more suitable for a bass. And then once I plugged this in and tried it out, I realized you could get all kinds of tones out of this. And I thought, this is like a factory. This is like a special console. And I thought, what can I call it? So fuzz face, fish face, everything beginning with F. And I came up with the idea, hey, Fuzz Factory. Wow. Now, as I said before in other videos, I'm pretty new to this whole area of building pedals, and I don't really use pedals I haven't used pedals that much in my own playing because I usually play clean stuff. Since I've built the fish face though, I've been using it a lot because I love it. Anyway, so I thought Fuzz Factory, no, someone's done that. So I'm not sure about the name. You guys got any good names? Go on, put it in the comments down below. Anyway, so this was a very rough version, hence the wacky wiring there. But basically, as you can see, every single resistor is replaced by a potentiometer. So basically, in the schematic, every time there's a solid state resistor in there, I've put a pot so that you can wiggle them and configure the thing. And also, of course, most important for this project was the effect of C1 and C2. Okay, and in dabbling round, to cut a long story short, spoiler alert, I found that C1 made a bit of difference in the amount of bass tone that was allowed in and hence got amplified. But the thing I found that had the most effect was C2 up here. which is normally 10 nanofarads. I tried 30 nanofarads, which had an effect, and also 100 nanofarads, and in the end, in this one, which I'm going to show you at the end what that sounds like, I replaced it with a 1 microfarad. Is it 1 microfarad? Yeah, 1 microfarad capacitor. So I've got 2 capacitors soldered onto this. Can you see that? 2 capacitors soldered onto this switch, so you can switch in between them. So the signal comes in through the center lug, say, and depending on which way you've thrown the switch, goes out through one of those capacitors. One is the original 10 nanofarads, and one is 1 microfarad. So it's 100 times bigger in value, and that does have quite an effect. Okay, right. So stay tuned, and I'll very quickly get into showing you this. Okay. Right, well, thanks for watching so far. Don't go away. I know this is a bit of a long, boring sort of ramble, and I said I was going to keep it short. We're up to 14 minutes at the moment. Okay, 14 minutes of me talking. Oh, I do go on a bit. Anyway, okay, so having built that box, I will get to the demo quickly, shortly. So having built the box like this, plugged it in and it works, it was great, but I don't like things flapping around and not fitting properly, and so I went and built. I thought, how can I take this further and make this a little bit tidier, and so that I can see what I'm doing more easily. So there we go. I've got a cake tin. Yes. Not only do we use food food tins to make things, and by the way, I showed you the baked beans tin amplifier, didn't I? I'm also working on this. This is a guitar amplifier you can take away with you. It, you know, would look tidier than this. This is my prototype. You take off the lid. Ha! There's the speaker. Yeah. And down here, there's the battery compartment. That is a guitar amp. Please tell me in the comments if you'd like to see this go into production, because at the moment I'm selling lots of fish face fuzz pedals, and you could have an amplifier to go with it. It's also got a speaker out option, so basically you can plug that into a big 12-inch speaker and it sounds great, believe me. Most of my amps have a speaker out option, so that you can wire a bigger speaker up if you want to. Right, little diversion there. Okay, so from the wooden box, cigar box version, I thought I'd tidy it up a bit, and the cake tin was a perfect sort of thing because it's a bit dusty. It's been lying around a bit. Anyway, cake tin was a perfect thing, like a ready-made enclosure, easy to drill through, plenty of space to work with there, and it's deep enough to put sockets on the side. Okay, and a foot switch. So this is my working version of the sort of fuzz factory thing. What am I going to call it? I had a name for it. Fuzz format. I can't remember. Anyway, it'll come back to me. So here we are. Here's the circuit again. And the idea with this was to use it possibly as a teaching tool or a tweaking tool, so that people who are into tweaking their pedals can get one of these and play about with the parameters before they actually decide how to set their own fuzz face, fuzz face clone circuit. So the idea is that you could configure it all by doing this, and when you've done that, you can, okay, turn it over, take the readings of the actual resistances from the pots here, put that into your own circuit, and you should then theoretically replicate the sound you create with this, but with only 2 knobs, possibly a switch in here. Okay, let me know if you want to see a video on that, because basically that would make an interesting video in itself, wouldn't it? Deep dive into playing with all the sounds available with this, and then see whether my theory of translating that, or transcribing that, as we used to say in classical music, transcribing that into one of these. Okay, that's another video. Okay, please like and subscribe. You know you want to. And hit the notification button and so on, and you'll see when that video comes along. Anyway, enough waffle. So here we are. Sorry, it's a bit dusty. Let me just give that a little wipe off a minute. Yes, need to wipe it properly. But anyway, so there's the circuit, the schematic, the standard Dallas Arbiter fuzz face circuit, sort of simplified, and well, not simplified much, but drawn out on the surface there, so you can see which controls these relate to in the schematic. So again, we've got the signal in which is down here actually, but then routed underneath right across the board. So we've got signal in coming in here, goes into C1, which I've put on a switch, so you can switch between 1 microfarad and 2.2. So we've got the original value there, 2.2. That's the original value, and you can put it to a smaller value, 1 microfarad there if you want. I could have a 5-way selector there, or you could sort of, you know, patch in one of the what are they called, copper sound type capacitor substitution boxes, and they're easy to make. I think I'm going to do a video on those as well. Anyway, so you know, you could have a 5-way switch there. I've kept it simple just for the purposes of this prototype. It's giving just the 2 values there, so 2.2 the original value, or 1 if you want to sort of try a smaller cap. Then we've got R1 over here, and basically the standard value for R1 is 33k. I've put in 100. Yeah, I've put in a 100k pot there, which means that if you turn down it, and it's not it's not audio, it's linear actually, yeah. So technically, if you turn it down to a third of the way, you know, a third of the way around, a third of 100, 33k. So that should be pretty close to a 33k resistor there. Same with R2, 330 ohms. I've put a 1k pot behind there, so you could go between 200, 330, 500 ohms up to 1000 ohms on there, and we'll see what that does in a bit as well. I've heard a couple of people, I think it was Marcus Reeves and also Joe from Hello Joe Sailor Effects, and also Josh from JHS Pedals. I think they've all mentioned the fact that this is one of the most important resistors in terms of the actual amplification volume of the whole fuzz face. So basically, if you increase that value, the thing's going to get louder. Now, these volume and fuzz pots are wired in the standard way. In other words, when you turn the pot up, the resistance goes down, which lets more of the signal through. These 4 resistors I've wired the other way around. I've actually wired them up so that as you turn them up, the resistance increases. Okay, and the idea behind that was so that I can test out and actually visually see what that increase in resistance, you know, I can actually say, well, let's turn it up or turn it down. So they're wired in a way opposite to those. Okay, so there's your 4 resistors. There's a feedback resistor there. That controls the amount of current signal that's going back into Q1 from Q2, from the emitter of Q2. Anyway, so it goes round and round, blah, 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 comes out. We've got C2 over here, and this is the most important one I found as far as the bass sound is concerned. There's your original 10 nanofarads, and here I've got 33 nanofarads, so that's 3 times. And I found that produced a significant change in the bass, amount of bass that's coming through the system. I decided to whack this up to the full 1 microfarad. So that's the same sort of switch as what's going on here, just to put things in context. Okay, so basically that's the circuit. Again, I'm still not sure what to call it. If you have any ideas, please put it in the comments. And I'll just give you a quick view of the inside. There you go, that's a bit tidier, isn't it? And I've written the values of the pots on there. And now, having taken all the resistors and capacitors out of the circuit, in a way off the circuit board, all that we're left with on here is the two transistors, Q1 and Q2. All these wires, you know, go off to the relevant resistors. So basically what I've done is I've sort of exploded out the standard Dallas Arbiter fuzz face circuit and put in a pot on every resistor. The 2 pots, fuzz and volume, they're already in the design anyway. In and out jacks, and the 9-volt adapter there. Okay, so you can see there I've wired 2 capacitors onto C1, and yeah, two different values there. Okay, so let's get onto the playing demo, shall we? Right, shall we use this one first? Yeah, I think so. Right, so come over to the bench and we'll tweak the knobs a bit and see what it sounds like. Okay, so welcome back to the bench. Here we go. This is the what shall I call it? Okay, for the purposes of this video, I'm going to call it the Fuzz Factory, and not to be confused with the other Fuzz Factory. No, Fuzz Fabricator. Let's call it the Fuzz Fabricator. Yeah, that makes things simpler. Okay. Right, so first of all, I've got my desk amplifier over here under my computer screen. This is bolted permanently into my desk, and it's just a useful little amplifier. Now you'll hear it buzzing away. Under the desk I've got a 8-inch wide range speaker. Okay, sorry, excuse me there. Right, so crazy jack amplifier, and I'm playing the old Squire telly. Now, hopefully you'll be able to hear that. It's not massively loud. Okay, right, so that's the clean tone, true bypass, okay. Let's turn on the fuzz. Now, right out of the box, I don't know whether I set this up, but that's not bad as it stands. Okay, I'm going to set up the standard fuzz face settings on this. So we're going to go with the 2.2 microfarad there. R1, I'm going to put round to about 1/3. And I have tested this actually. I've turned the knobs and then turned it over and tested the voltages using a multimeter. And it's fairly accurate. So this method. So up here 1K, again 1/3 of the way around for that. So about, say there. This is a 20k pot, was it? No, I think I used 10. I'll have to check, hold on. No, it's a 20k pot. So if it's a 20k, should be just under about halfway round. So say about there. And R4 down here, I'm using a 250k pot, 100k. So what's that? Halfway would be 125, so a bit less than halfway. Okay, so that here, oh, I forgot to mention, I've got a 100 ohm resistor here to limit the minimum value of the fuzz pot here. That I'll talk about that in another video, I think. Basically, if you take that out, you get some pretty wild results. If you do that, it limits it a bit, makes it more sensible, if you like, sensible fuzz. Okay, and up here we've got C2 and 10 nanofarads. That's the standard position. Excuse my lousy Hendrix. Right, so I've got the volume full and the tone up full in the middle position on the telly. I'm going to, I think in future videos, mic these up a bit, but anyway, hopefully the phone will be picking up enough. So, quick demo. Let's see what happens when we change the value on the C2, okay? Now I don't think the phone's going to pick this up enough, but when I flick that switch, the bass sounds in the mix come through. Now hopefully that's the bass end of the guitar here. You'll hear that the bass is coming through, and that's just the difference between 10 nanofarads and 33 nanofarads on that one. Okay, let's just quickly mess around with some of the other values so you can see what's going on here. Say for example the R3 here, which is the most important resistor I understand in biasing Q2. Okay, so that's up full. So R3, if you turn it right down to probably what's about sort of half a K or almost zero resistance, you get an almost clean sound. So I've played it quite hard that last little bit there. Okay, so that's R3. That's the effect there between clean and fuzzy. Let's see what happens when we turn up R2. So okay, so that's louder. Turn R2 right down. There we go. So it seems that what people have said about that affecting the volume is true. Quite apart from what the volume control itself is doing over here. So if I turn that up, okay, let's put that back. Let's turn R3 back to normal, if you like. Let's try R1. Okay, that's interesting. If I turn R1 right down to 0, it's like a switch and turns everything off. So it doesn't seem to make much difference to the tone, apart from switching it right off the bottom end. It doesn't seem to do much, but that feeds into everything else. So, and as they say, all of the components, it's a simple circuit, but all of the components have an effect on each other. It's like a balancing little network. Okay, let's adjust the amount of feedback that's coming. So the signal goes into Q1, is amplified a bit, goes into Q2, and then some of that signal is fed back to Q1. And this R4 is what affects that. So if we turn R4 right down, so very little of the signals going, so if we turn R4 right down, you get an almost clean but quieter sound. We turn R4 up, so don't forget, if we turn the volume, if you turn the knob that way, that means the resistance is going up. So the more resistance we give to that, the louder it's actually getting. So the more resistance we give to there, obviously you would think the less signal's going back, so more of it's getting pushed up this way. Okay, so this was the whole idea of this, you see, to be able to understand, to get to grips with how the whole circuit is balanced. That's really nice, quite a hard-edged fuzz. So there we've, hopefully you can see the settings. I'm going to have to do a detailed sound demo of this, I think, in which I map all the settings. Okay, so with all those settings here set as I have, that the effect of R3 changes again. Right, so say we've set up that sound. Let's now kick in our bass switch. Sounds very Les Paul-like, doesn't it? So hopefully you can hear the difference that switch makes. Okay, I haven't even messed around with the fuzz yet. If I turn the fuzz up full, okay, you get a more spitty sort of sound. All the time, everything I've done so far has had that 100 ohm resistor in play. So it's a 100 ohm resistor just before this fuzz pot here, and that sort of tames things a bit, because I found that with the default circuit, without that, things get a bit wild. Do you want to hear it? There you go, can you hear that? Okay, so there it is. Some of you might actually like that. Nothing wrong with that. You know, experimental. So there you go. So that's the purpose of the 100 ohm resistor there. Now I'm actually thinking about turning this into a pedal. What do you think? And if so, what name should I give it? Please like and subscribe. Hit the notification button if you want to find out if I do a video on that. Okay, time's getting on. I'm rambling on a bit, but hopefully that will have helped you to see how the basic schematic, the Dallas Arbiter FuzzFace circuit can be tweaked by controlling each individual component and produce quite a range of sounds there. Okay, I think I'm going to have to do a proper demo at some point where I mic up my amplifier and also stop the humming because of all the electrical equipment around in a future video. So please like and subscribe if you want to see more about this. I think I'm going to go further with this, and I think I'm going to actually build a pedal so you can actually tweak this stuff yourself. Right, okay, so there we go. Final bit of the demo, and thanks for watching all along if you've stayed with it this far. I'm going to take what I applied there and put it into this actual unit, which is going out hopefully later today, or no, not that one, tomorrow probably. By the way, that's the prototype, and when I put this on and mentioned it on Anderton's website, a guy from Anderton's got back and said, "Oh, it looks like a rat's nest in there." Yeah, like I said, you try putting a fuzz pedal inside a tuner tin. Anyway, it's tidied up a little bit, isn't it? Right, so this one, okay, let's go ahead and plug it in. there's something wrong with this. I'm going to show you. This is what I did just now, and something I always do when I'm making these. So I'll just go through the process again, just to show you what happened. Right, so plugged it in like this. I thought, okay, that's looking good. Plugging the power here. Now the switch is still dangling out the side because I wanted to make sure I'd sorted this out before I actually go and install it in there. But basically that switch will go in that hole there. That's on, that's off. Okay, let's see what happens. Okay, so we've got sound. Turn the volume up. And yeah, my switch works. And then I thought, what's it like clean? And I realised, whoops, I hadn't soldered up the last little bit there, the bypass part of the circuit. It's one tiny little wire that goes across here, and I was going to do that in this demo, but I'm not going to bother now. I'll do something like that another time. I just wanted to show you the first time I heard this working myself with the switch. So, as I said, on this one, we've got the switch toggling, C2 switch toggling between 10 nanofarads and 33 nanofarads. In this one, we've got your standard 10 nanofarads on one capacitor and 1 microfarad, which is 100 times bigger, on the other one. So this is the difference. Okay. Right. I'm not sure which one that is. I think that's the bass one. So flick it the other way. Yeah, that's the standard setting. So that's the standard setting. Here's the bass. Can you hear that kick in? Out. Okay, I'm going to stop it there because I don't want to annoy the neighbours anymore. But I think that proves the point. So here we are. This is C2, capacitor 2, in the FuzzFace circuit. Inside the Crazy Jack fish face, and with a simple toggle switch like that, you toggle between much more bass tone coming through and the standard signal. So all I've got to do now is basically I'm going to cut the wires here, solder this where it should be here, push it through that hole, do up the switch, and that's ready to go out the door. If you're interested in having one of these, the bass version, please let me know in the comments below, or contact me or message me through the eBay shop. Crazy Jack's Telly Shack. Search Crazy Jack amplifiers or Crazy Jack fish face to find me. If you're interested in a bass version of this, let me know, because if it's popular enough, I'll make a few of these, and you'll be able to get it in brine, sunflower, or any of the other flavours available. Okay, right, I've been Crazy Jack. Thanks for watching. Don't forget, please like and subscribe. I'm aiming to get to 10,000 subscribers by Christmas, and when I hit 500, I'm going to be giving away, yes, giving away a genuine Crazy Jack fish face. Okay, you know you like it. Thanks for watching. I've been Marcy Harvey, aka Crazy Jack. Over and out. Telecaster man, tell it in my hand. Telecaster man, tell it in my hand. When I try to tell my baby, she just don't understand. Telecaster man, Telecaster man.
new tunes